The Python interpreter is an extremely useful tool for performing calculations, investigating code behavior, doing documentation, and even help with debugging. The Python interpreter will read your input, evaluate the code, display the results, and then wait for your next input. This read, evaluate, print loop is commonly referred to as REPL. Note that REPL is a general programming concept that is used with many programming languages. For Python, we tend to just refer to it as the interactive Python interpreter. We can access the interpreter by opening a terminal and typing the Python command. Note that you might need to use the command Python 3 depending on your operating system. Notice that the Python interpreter is indicated by the 3 arrow symbol. You can expect to see this often in code samples and documentation online. It represents the Python interpreter and is not actually part of the code. This is just something you need to be aware of when you copy and paste code.
You do not need to copy and paste the 3 arrows. It happens to all of us. We all do it, and we never admit it.
Now that we have the Python interpreter open, let's take a look at some of its common use cases. Let's get started by performing quick calculations and running code snippets. While learning Python, you should strive to use the interpreter instead of your local calculator application. Say, for example, you wanted to know the largest value for an unsigned 32-bit integer. You can calculate that value using the Python interpreter. Notice that the REPL displays the result of the calculation without an explicit print statement. This immediate feedback makes it easy for code exploration. Next, let's take a look at a confusing code snippet. Perhaps you found a complicated list comprehension that you would like to see in isolation. Let's put it in the REPL to see what happens. And you can see the results like this, and you can use the up and down arrows to browse through your previous commands. And now we can go in here and modify some of the values if we wanted to. Exploring programming like this makes it easy to compare the code with the results. Another extremely helpful use for the interactive interpreter is for exploring code documentation. Say we wanted to create a dice game. Let's attempt to simulate a die roll by creating a random integer. We begin by importing the random library, which is included with the Python standard library. Then we can use the dir function to display the properties and methods of the random library. Here we can see a method called randint, short for random integer. We can now use the help function to learn more about how to use randint. With this newfound knowledge, we can simulate the behavior of a 6-sided die by running the code random.randint with the parameters 1 and 6. Using the up arrow to run the same command over again, we can see the result of multiple die rolls. Finally, it is useful to know that the Python interactive interpreter can help you level up your debugging skills. We're not going to get into the details of debugging in this lesson, but let's take a quick look at how to apply your knowledge of the Python interactive interpreter to debugging. To demonstrate this feature, we'll create a simple while loop in VS Code, then set a breakpoint, and run the program with debugging. Let's run a couple of steps. We can see that it's displaying the results. And then if we go over here to the debug console, we can now access the interpreter. From here, you can execute Python code with access to your program's current workspace. To demonstrate this, let's modify the value of x. Notice that we skipped the value 3 in the results based on the modifications we made while debugging. This can be very helpful for working through tricky bugs in your code, and we like helpful things, so like the video. Unfortunately, the Python interactive interpreter is not always useful. For example, when typing complicated or nested code in the REPL, it can be quite bothersome. Let's expand that list comprehension from earlier to demonstrate a few levels of code depth. This is fine when it works first try, but if you create errors or you want to run the code again with different values, it can be hard to edit in place. These problems only get worse if you try to create functions and classes in the REPL. All of a sudden you have a bunch of objects defined, but it is hard to edit previous sections of the code. For this reason, the REPL is bad for writing and saving entire programs. Just use a .py file when things become too complicated for the REPL. If you want a larger, more powerful environment for data and code exploration, take a look at Jupyter Lab. Notebooks combine the flexibility of the Python interactive interpreter and the persistence of program files. They are a friendly environment for editing and running small blocks of code in a single workspace while maintaining easy access to the code. We're all done with the REPL, but how do you actually leave this environment? It's easy. Simply call the Python exit function to return to your regular terminal. If you found this lesson helpful, be sure to like the video and leave a comment below to let us know what you want to see next. Thanks for watching.